Hi all, this is Mr. Yeager for chemistry. We're looking at Lewis dot diagrams and Lewis structures for covalent compounds. These are some drawings that we do to kind of clearly show, not clearly show, but I mean basically better show the arrangement of the electrons, to show bonds between compounds, and to basically show what a structure might look like. It's also very useful in upper levels of chemistry to illustrate the actual shape of the molecule. We'll look a little bit at polarity and how you know whether something's polar or non-polar, but basically it's just drawings is what we're about to do. So here we go. Again, this presentation was created by another excellent chemistry teacher, and I'm just using it. So here we go. All right, there's our course standards. So what is a Lewis structure? Okay. I kind of already stated, it's a way to show where all the valence electrons go and how they come together between two atoms to form a covalent bond. One of the things that it really helps us show is what's called the octet rule. And the octet rule is where an atom will either try to gain, lose, or share electrons in order to have what appears to be 8 valence electrons around it. Again, 8 valence electrons is the magic number of stability in chemistry. Okay, and so when an atom has 8 valence electrons, it is in its most stable form. This is why noble gases don't need to bond with anything. They already have 8 valence electrons. They already have this full outer energy level, is another way that we look at it. And when that's done, the overall atom itself actually goes to a lower energy state and therefore is perfectly happy the way it is. The thing is, most atoms aren't in this lowest level state, and therefore they need to do this gaining, losing, or sharing of electrons to get to 8. All right. So when we draw these, we're going to show electrons basically as just dots. Now we're going to try to exaggerate the size of the dots. You don't want to just kind of dot your paper with your pencil, but you actually draw in a little dot. And then we're going to show bonds with lines. Now the big things we kind of already mentioned back in the covalent bonding lecture is that, again, a single bond, while it's a single line, it represents 2 electrons. Okay? So again, a bond is 2 electrons when we're talking about covalent bonds. Double bonds is going to be 4 electrons, but we're going to see we draw that with 2 lines, and then a triple bond would be 6 electrons being shared between them. So we draw these lines, and each line represents 2 electrons. So how do we kind of put these things together? Okay, how do we sketch out Lewis structures? So number one, you're going to count up all of the valence electrons that the compound has. So I will give you a compound, and you go through and go, this has this many valence electrons, this has this many valence electrons, and this has this many, and you add them all up. And so we need to figure out the total number of valence electrons. Number two, you place the least electronegative atom in the center. Okay? So what I want you to remember here, okay, I'll draw a little periodic table with this. There we go. All right. What I want you to remember is that fluorine is the most electronegative element. All right. So as I move away from fluorine, electronegativity will decrease. All right. And so we are primarily only using elements on this. We will only use elements on this side of the periodic table. I'm going to change colors here. We're only using elements on this side of the periodic table. We're not going to use noble gases, so they're out. Okay? So we're not using a lot of atoms. So when you're trying to figure out which element is the least electronegative, you're trying to use the atom that's the farthest away from fluorine, and that's the one we're going to try to put in the center. Another way to think about this as well is usually the atom that needs the most valence electrons still to get to 8 will also be in the middle. Okay, so carbon, silicon, nitrogen, those elements are generally the ones in the middle, and again, they're found mainly over here on the left side there. Okay. You're going to arrange the other atoms around the central atom, and we're going to connect each one with a bond, okay? Because we know they're all going to connect. So we're going to have a central atom, and then all the other atoms are going to connect to that central atom, all right? So that we get that part. Then you add in any unshared pairs of electrons by drawing in additional dots, and again, you'll see this all in a moment. So each atom will have a full octet. The only exception to this is hydrogen. Hydrogen only needs 2 electrons to get a full outer energy level, so it doesn't follow the octet rule in the way of 8. It just needs 2. So you'll see in a moment when we have hydrogen, we just connect a line to it, and then you're done. You don't need to draw any additional dots. Other atoms, though, we're going to have to maybe draw multiple bonds. Okay, so there might be multiple lines if there's not enough atoms for you to connect around one to get 8, or you just add in dots. You then check the structure, ensure that the total number of electrons used is accurate, and atoms have octets. So I'll show you that as well. All right, so first thing we're doing is showing what is electron dot notation. So we're not doing structures yet. This is very straightforward. An electron dot notation basically just involves writing out the chemical symbol. So carbon would be C, and then you draw the valence electrons. You draw dots for the valence electrons around that atom. So carbon has 4 valence electrons, and therefore it needs 4 dots. Now the last rule about this is we put dots on left, top, right, or bottom of the element. We don't just randomly put the dots like in corners and stuff. They have to be on the left, the right, the top, or the bottom of the chemical symbol. And we don't pair dots until we have to. So you can see what I did there is there's 4 spots, there's 4 valence electrons, so they're all going to be on their own side of that atom. If I go to nitrogen, nitrogen has 5 valence electrons. So what happens here? I put 1, 2, 3, 4, and then 5. So I pair up one of the sides. It doesn't matter which side you pair up. I mean, because I started on the left, I went around, and then I'm going to go around again if I needed more. You could put that second dot wherever as long as there's 5. So you could have been like, I'm going to put the dot here, and the other dot's going to go on top. Fantastic. Good job. Okay, so some other ones, more dot notation. I have oxygen, 1, 2, 3, 4, 5, 6. Oxygen has 6 valence. Hydrogen has only 1 valence electron. It's going to be the only nonmetal on the left-hand side. It is the only nonmetal on the left-hand side. We're not going to use any other metals. We're only going to be, again, looking at atoms that are in the nonmetal section of the periodic table. This is the only one that's going to be 1. All the other ones will have 4, 5, 6, or 7. Okay? But there you go. You put 1. Again, do I have to put it right there on the right-hand side? No. I can put it on the bottom. I can put it on the top. Sorry, just draw a straight line there. Wherever. Just as long as there's 1. There's more. Let's do this again. Chlorine. Chlorine has 7. So 1, 2, 3, 4, 5, 6, 7. Sulfur has 6. 1, 2, 3, 4. Hell, look what I'm doing. 5 and 6. Look at that. Okay? And again, you can see I'm filling in the dot. What I don't like to see is when students are like dot, 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 dot. I can't see that very well, okay, on a test, especially if it's in light pencil or something. So don't be mean to your teacher with that, all right? The most dots you should ever draw, I'm going to mention this too, the most dots you should ever draw is 8 dots, okay? 1 to 8 dots, all right? I always use this as an example. In the past, I've given this one on a test or a quiz, xenon. Xenon's a noble gas, so it has 8 valence, okay? It should only have 8 dots. 1, 2, 3, 4, 5, 6, 7, 8. I have actually seen a person go, xenon has 54 electrons. I think that's what it is, 54. I'm double checking. I want to get this exactly right. Yeah, 54. I've actually seen somebody draw in 54 dots. It was the most impressive thing in the world. They had all these dots up there, and all there, and all there, and all down here, and down here, and down here, and over here, and over here, over here. And I just had to look at that and be like, that is very, very impressive. Wrong. Okay? So there should only ever be up to 8 dots. 1 to 8 dots. All right. So here we go. we're getting to structures now. So we're going to do a few of these. I don't feel like I need to probably do 20 of them to hopefully have the idea taken in. So we're going to follow the steps that are given in this. So I'm given this compound. You can see I have a carbon, I have 3 hydrogens, and then this is an iodine. Okay? So the first step is I need to count up all the valence electrons. What is the total number of valence electrons? So carbon has 4 plus hydrogen has 1, but there's 3 hydrogens. Okay? So carbon contributes 4. I have 3 hydrogens, each contributes 1, so I need to multiply that by 3. And then iodine will contribute 7. So that means I have a total of 4 plus 3 plus 7, which is 14 electrons. So when I'm done this, I will go through it and show that there are 14 electrons, but the structure in every atom will think that they have the correct number, or 8 and 2 around them. So what I do is I go, okay, I have CH3I. C is the farthest away from fluorine. Okay, I have F, O, N, and C, and then I's down here. I get I's kind of also just as far away. But again, the other way to kind of look at this, and I know hydrogen's always on this side, but hydrogen will never be in the middle. Let me be clear about that. All right. C is going to be the least electronegative element. I mean, I is up there too, but the issue with I is I can only form one bond. It only needs one more electron, so it only forms one bond. So it's not going to be in the middle. Okay. So carbon's going to be in the middle. So there's carbon. And then there's 3 hydrogens. So let me draw hydrogen around it. Hydrogen, 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 and then iodine. Well, each one's going to just connect with one line. Okay, I have to connect to all of them, and all of them are going to be connected by one line. What that means is if I now look at this, if I look at this where, I might have to erase this some, I focus on just the carbon. The carbon now looks like it has 8 electrons around it because, again, each line is 2 electrons. 2, 2, 2, and 2. And the idea is carbon is feeling all of those bonds, so therefore it has 2, 4, 6, 8 electrons. So carbon is happy. Then if I focus on any individual hydrogen, each of the hydrogens, we said, only need 2, and they all look like they have 2. Now the only one we have to do anything with is I. I has 7 valence electrons, so if I drew out I, it would be 1, 2, 3, 4, 5, 6, 7. It has this 1 electron to share, which it shares with the carbon up here. So we have iodine, and so what I need to do is I need to fill in the rest of the dots around iodine. And that would be now showing that it has 8 valence. Otherwise it only has 2, and that would be incorrect. So if it's not hydrogen, we need to fill up the rest of the electrons around that atom. I don't need to do any electrons around carbon because it has 8. I don't need to do any around hydrogen because they have 2. So that's that one. NF3. Well, we know F is not going to be in the middle, so we got N. Okay, so I'm going to put N in the middle, and I'm going to put F around the side. F, F, F. I'm going to connect each one with a line, and then I fill in the rest with dots. I need 2 more dots on the nitrogen. I need all of these. I'll show you another method too to be kind of clearer with this. Not really in the instructions with it, but you can do it that way. But there you go. That would be my structure. This one has 8. This one has 8. The bottom fluorine has 8. And then nitrogen has 1, 2, 4, 6, 8. So again, it's all achieving the octet rule. All right. So I'll do the next one with a slightly different method to see if it might help you go, wait, why are there dots on it? So for this one, I have H2SE. I said H2 is never in the middle. So I'm going to draw, I'm going to draw SE. All right, but let's go ahead and draw out the dot diagram first. Sometimes it's good to do that. 1, 2, 3, 4, 5, 6. Selenium has 6 valence. Oops, shoot, I messed up. Well, we'll do it with this one. That's okay. We should have gone back and been counting. I didn't count everything out there. All right, and that would be, I guess, the other method you can use with it. So 1, 2, 3, 4, 5, 6. Hydrogen It's going to be over here. It has 1, and hydrogen is going to be down here and it has 1. That's where the line forms, is between those electrons. And then there you already have the dots around everything. What I should have been doing, I apologize, is again, I haven't been going back and doing my total amount. So I have 2 times 1 electron from hydrogen plus 6, so I have a total of 8 electrons. Okay, is what I'm looking at there. And you can see here, I still have only 8. I have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, and I have a completed compound. Selenium feels like it has 8. All right, NOF, NOF. You remember this from intermolecular forces, but this is the actual compound of NOF. So this one's a little trickier. I have N, let's do our numbers. N has 5, O has 6, F has 7. So that's a total of 18 electrons. All right, so I have N, and I'm going to put O on one side and F on the other side. Okay? And the issue here is, and this is where I feel like you're going to have a little bit of issues if we don't draw it out. So let's go ahead and draw this on out. So we know O and F are going to be on either side. So if I do this, I have 1, 2, 3, 4, 5 for nitrogen. Fluorine, I have 1, 2, 3, 4, 5, 6, 7. And then O, I have 1, 2, 3, 4, 5, 6. There's a reason why I'm putting them where they're putting. So I can see that there will be one bond between N and F. Okay? Because nitrogen is the least electronegative. N and F. Then what I have here is I got a bond right here, and this is the first time we're seeing it. There's going to be a second bond between N and O. So I should redraw it. It'll be N double bond O with its 4 electrons left over. Single bond to F on the other side, 1, 2, 3, 4, 5, 6, and then 2 electrons still left on nitrogen. If I look at this one, I have 8 valence around fluorine. I have 8 valence around nitrogen. 1, 2 dots, and then this is 2, so 4, 6, 8. 8 total for nitrogen, and then over here, 2, 4, 6, 8 for oxygen. And if I count it out, I have 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons to show. All right, another one. Give you 2 more. I got carbon, 4 plus, hydrogen's 1, but I have 2 of them, plus 6. This is equal to 12 electrons. Okay? Carbon is the least electronegative, or needs the most bonds, so carbon's in the middle. It's going to form with 2 hydrogens, 1 and 1, we know that. And then I have Se left over. Well, this could be a little confusing because carbon has 2 other electrons. Se is just like the one we just did. Oops, let's go back and I'll do it that way. 1, 1, 1, 2, 3, 4, total 6. It's going to form a double bond. So if it seems like you don't have enough situation, like, you don't have enough electrons around it, that's when we're going to start forming these double and triple bonds. So this would be C, Se, 1, 2, 3, 4, and then H, and then H. And there's your compound. Last one, PBr. So P has 5, Br has 7 times 3. So 5 plus 21 is 26 electrons. This is going to be easy. I have P, and it's going to have 1 Br, 1 Br, and 1 Br. And guess what? Then there's just a bunch of dots. Okay? So the last thing I'm going to show, oh, look at that, we did all of them. One thing I just want to show real quick with this is with the periodic table, you can also figure out the number of bonds that the atoms want to make. So if I'm talking about the halogens, okay, F, Cl, Br, and I, their structure, their Lewis dot diagram always has 7 dots. They have 7 valence. That means they want to form 1 bond. Okay? So those elements are always going to only form 1 bond. If I go to the next group, O, S, Se, those are usually the 3 elements you're going to use. These guys have 6 dots. 1, 2, 3, 4, 5, 6. So they're going to want to form 2 bonds. Then you go to the next group, N, P, A, S. Guess what? They have 3 lone electrons. They're going to form 3 bonds. And then finally, you have carbon and silicon. Those are really the only 2 you're going to use. They have 4 lone dots. They're going to want to form 4 bonds. Now that can be done through a double bond, triple bond. Nitrogen can have a triple bond, a double bond, or a single bond. Oxygen can have double or single. The halogens can only have single bonds. So that's another way to look and kind of configure how to create these different compounds. All right, thank you.